See, I reactivated this little quiz, the ProctorU review check, so you can get everything running. Basically, you got to go to ProctorU if you've not done it, because I know some people that may not have done this. I mean, I could probably find out if I wanted to, but it's a lot of work to get in there because we had several trial runs with the ProctorU review. I even had one test that I didn't mean to have ProctorU review, and actually I think it's ProctorU record now anyway. But anyway, all you got to do is go to ProctorU. You got to have an account there, create one, then you go back to this and you click on it, and you got to download that app. There's an app, and if you're confused, over here, there's the information for that. Okay, and it says prior to midterm, but you can still do it now. But that's the information you need right there. Both of those can help. There's even a link in there to tell you where to download that app, because you can't run it without the app. And if you wait until the last minute, like I said, I got a whole different schedule next week, so I may not be able to help you. So you got to make sure that's working. If you want to do it, as soon as you can, and you got questions, that's fine, but don't wait. All right. Oh, I know what I was going to also say. And I'd like you to do this for me under quizzes. This is just a survey. See, it says a formative evaluation survey. If you would fill that out, I'd appreciate it. You can do that now for all I care. Just like I'd have you do it. It's just to get some feedback, to know how to improve the course for next time. All right. Let's see. I think that's all I wanted to say. And then you can check the dates here on everything's kind of on here. I've got everything. You'll see the final exam come up. I believe it'll come up on Monday, and then be available Tuesday and Wednesday. And then we'll talk about that a little bit more on Thursday. Because now we're still looking at test 5, so get that out of the way. Make sure you do your practice tests in these 2 things, because they'll help you prepare, because you'll be able to see what you miss when you're under testing pressure, which is really what you got to work on when you're going to be taking tests. Because it's one thing to do homework, because homework you got more freedom and looking and showing me how to do this and looking at the book or looking at an example, and you don't have that with the quizzes and the tests. So that's why these things are important, because you got to step up the game, and those are meant to be stepping stones to get to the real test. There's not a whole lot of value in these, a whole lot of percentage value, but it's meant to be a risk-free way of finding out what you know. So, anybody got any questions? So the last week of class, we're in the last week of class, and then exam next week. All right. All right, so let's get started on the review. If you got any questions, there's 2 reviews in here, incidentally. One's got the answers, so I'm not going to concentrate on that. It's got a key, so I'm going to work on this one since it doesn't have a key, and then you'll have the answers worked out as we work them out in class. And then if we have a little bit more time, we may get on to some here that weren't mentioned here. This one has a few more problems. I think this one has 25, and this one's got 20. All right, any questions? All right, so I'm going to just fish for some answers here. What do we need to do on that first problem? What do we need to do on that? Because it says use the product rule to simplify the radical. Remember the product rule, what that refers to is the fact that if we have a radical, we can use multiplication to factor the radicand, that part inside of the radical, and break it apart. And usually what we want to do is factor out any perfect squares and then break that down. And if anything is not can't break down any further into any more perfect squares, then we just leave that in there. So let's give it a try. So you try them, and then tell me what you get on this, and I'll give you a few minutes. All right, so the product rule is simply when we break this down. And 150 is divisible by 25, which is a perfect square. And how many times does 25 go into? That's supposed to be a multiplication. How many times does 25 go into 150? Yeah, 6 times. Good. So now we can just break it down. The 6 can't break down any further. It's only got 2 factors. It's only got factors of 2 and 3, neither of which are a perfect square. So that's going to stay in there. This right here breaks down as 5, and then the square root of 6 is multiplied by it. Now, just to kind of show you that these two things are the same. All right, 150 square root is 12.25 more or less. The reason why it fills up the screen is this is an approximation, and no matter how many decimal places you go out, it'll always have another one to add there to it. I mean, I can't even count how many that is. That's a bunch. I could, but I don't want to mess with it right now. I'm just going to take square root of 6 and multiply it times 5. And see, we get the same value, 12.25 more or less. See, this is what they mean by an exact answer. We could round it off to any place we choose, but that's not an exact answer. So that's the purpose of those square roots staying in there. If they're not perfect squares, they stay in there because that is an exact value. All right. You got to remember about what's the base for a exponent. And if there's no parentheses, then the exponent only belongs to what it's touching. So this right here, because remember this right here, when you got a fraction as an exponent, that's the square root thing. If there were a 3 there, then it would be a third root. You put a 3 there. There's nothing you can really do to simplify this. If you see something, let me know. But as far as I can tell, all we can do. If there had been parentheses around the whole thing, the 4, there would be a 4 come out, but it's not. The 16 is not part of the base. All right, so let's just do a little bit of work down here. That one up there didn't really need any work. This one right here is inside. It's negative 64 x to the 15th. And I suppose that's what they want right here. Because that's the radical notation, but it's not simplified yet. Now we can do what we've done before, and like I said, we can break it up if we want to. That'll help. This is a cube root. Oops, it's x to the 15th, not 15th. So, numbers work slightly different than with variables. A variable is easy because 3 goes into 15 5 times, and so that's the simplified part. Now, if we were to write this right here as the cube root of negative 4 cubed, which is what 64 is, then the 3 undoes that 3, and we're left with a negative 4. All right, but at any rate, the cube root of negative 64 is negative 4. All right, give number 4 a try. So remember, if you got a negative sign in the exponent, that means take the reciprocal. That's what I would suggest doing first. So and just refresh your memory about the rule. Let's see, it's A to the m over n is the way it appears in the text in my math lab. It's the nth root of A to the m, which is also equal to, and the more useful one for you folks in this class, is this. You can put it on that numerator, either on the inside or the outside. Usually this is going to make more sense. So this is that rule. And then, of course, I guess you could say the smaller version of it is A to the 1 over n is equal to the nth root of A. If there's no numerator, but if there's a numerator, then it's doing that. All right, so first step on this. So then what can we do? there's a 3 in the denominator, so that means that's the index for our radical. So cube root of 125, and this is still over 1. And then once we figure out what that is, we can square it. So cube root of 125 is what? I don't have the calculator like you have. Like I said, you can use the one in the My Math Lab if you want to. For the most part, that'll do everything for you. This one doesn't have any kind of roots other than the square root. So I can't really show you. But anyway, that's the cube root of 125, which is 5, because 5 times 5 is 25. And 25 times 5 is 125, all squared. Yes, that's right. That's 5. So then this ends up being so right with positive exponents is this one. So they want 2 answers. And then the simplified version is just 1 over 25. Okay? Makes sense? Any questions? All right, now this is one where we're asked to add them, and we cannot add them unless they have the similar radicals. Okay? We got to have the similar radicals. No way around that. We can't put them together. So let's see if we can make them so. Now, there's an x here, so that can't come out. But here, x cubed can. So let's just see what we can do. It looks like what's going to stay in there is the 3. Well, let me put the x squared here. This is the perfect square. And then this one is the 3 and the leftover x. All right. The x is going to stay in here. But the 75 can be broken up as 25 times 3x. And you can see those are starting to match now. All right, so square root of x squared is just x. So 6x square root of 3x. Square root of 25 is 5. And what's that going to be? 5x times 5 is, yeah. All right, so now see, this part is the same. All right. So it's got a variable and it's got that similar radical of 3x. So all we got to do is just add this and that. And that gives us 31x all right, any questions on that? They won't add unless you got similar radicals and variables, just like with, plain old like terms. The like radicals are very much just like terms. The only difference is the 3 isn't a variable. Now, there is an x inside of there, but the 3x is the same for both of them, so we can, and also the x in front is a multiplier, so we can just add the numbers now. See this right here? That was a perfect square. We're always taking out perfect squares. We're always taking out perfect squares. And here, x cubed is not a perfect square, but x squared is, and the other one stays in there. That's the remainder. If you want to handle it like this, remember there's a square root, there's a 2 there. 2 goes into 3 one time, so 1x comes out, and the 1x stays in there. So there are a couple of different ways to handle it, but that's a perfect square in there, x squared. So I use that product rule to break them up. Does that help, Amy? So, all right, now we're going to do multiplication now. And remember, with radicals, it's really the same old process. You got first, outside, inside, and last. All right, so I'm just going to kind of put them together first. So that's when they were multiplying it times that square root of 3. So that's your first. Outside is positive times positive. It's a 5. Terrible looking 5, but that's that one right there. That's the first. Outside. The inside's going to be negative because you got a negative times a positive. So it's negative 2 square root of 6. So that's your inside. Negative times positive is going to give us another, on the last, it's going to give us another negative. Just got to see you're multiplying here. I guess I should leave some parentheses. And that's your last. All right, so let's flesh these out. 4 times square root of 3. So there's no number to match the 4, so we because that's essentially just a 1 square root of 3. All right, and then the other part is square root of 3 times square root of 3. So when we have two radicals multiplying, we just multiply the numbers on the inside. Here, it's 4 times 5. You multiply the numbers. And then square root of 3 times square root of 6 is square root of 18. Minus minus 2 doesn't have a number to multiply, so we're just going to put it there. And then it's square root of 3 times square root of 6 is another square root of 18. And then the last, you got 2 and then square root of 6 times square root of 6 is square root of 36. So there's our 4 terms. They're shaping up now. We got plenty of room here. So our square root of 3 is, square root of 9 is 3, I'm sorry. 4 times 5 is 20. And then the 18, you know what, I'm going to leave it as 18. We'll simplify it in a minute. When we get them both together, I'll show you. It'll be a little bit shorter. This way, I think. Can't not do it, but. And then square root of 36 is 6. So that's 20 minus 2, so that's plus 18. Square root of 18. And then that's negative 60. All right. So 60 negative and 20 positive is 48, right? 48 negative. And then plus 18 square root of 18. Now, the 18 is not simplified because the 18, not the 18 in front, but the 18 in the radical. All right, so that's square root of 9, which is going to be 3 square root of 2. Times 8 is, let's see, 18. That's 54. Square root of 2. I see any issues? I think I got it. All right. So it's a messy one, but that's a good one to practice on. If you can do the long, messy ones, then you shouldn't have any problem with more, because test ones usually end up being a little bit shorter and easier. Not always, but. All right. Now rationalize the denominator. Anybody remember what that means? And we need to have an exact answer. In other words, if we're not going to have any more radicals in the denominator, that's the idea behind rationalizing the denominator. But we do have to leave any radicals that appear in the numerator. We're not worried about the numerator, because what that's going to do, if we have a radical that can't be broken down in the numerator, that means it's going to stay in there and it'll be the exact answer. All right, so first of all, the best way to approach this is if this can be broken down, we'll do it here. Because we can easily multiply the numerator, the denominator by square root of 24x, and then the 24x is going to pop out, but we still have to simplify it up in the numerator. So let's do it now, and that'll make our math a little bit easier. So this is 4 times 6x. So square root of 4 is 2. All right, now we're going to multiply by that radical down there. So I'm writing this again, and let's just say, I want to try this a little different color. So I'm going to multiply top and bottom by that same radical, square root of 6x. And this is because, essentially, if we multiply a radical by the same thing, a square root by the same thing, in other words, if we square a square root, what's inside of it comes up. That's what we were doing last class period, where we were solving those, what do you call them, what do they call it? I forgot that. It's called completing the square, but square root property is the only part that you looked at. It's kind of the last part of this thing called completing the square. But that one, you're taking, you're taking the square root of a square to undo the square. And then in this part right here, radical equations, we were squaring radicals to get the insides out. So up here, we're just going to multiply that. And down here, it's going to be 2 times. And I'm going to put that's what that is. It means we're multiplying by the same thing, so it's just squaring it. So it's going to come out. So that ends up being 5 square roots of 6x. And then here, we're going to multiply 2 times 6. And as long as there's no common factor between the numerator and the denominator, then we're finished. If there, let's say there was a 6 here instead of a 5, 6, we could put that as 1/2, but that's it. All right, any questions about it? Rationalizing the denominator. That's a very basic one. Where we got just one term. All right. So now we just want to do the same thing, an exact answer. So we're going to leave any radicals as long as they're not in the denominator. Now, to handle one when we have a binomial down there, we're going to multiply by what's called the conjugate. It's going to be the same thing okay, and if we do it down here, we're going to put it up there as well. Remember, the conjugate, if we use the conjugate and multiply conjugates times one another, we lose all of the insides. And in other words, we're not going to have any more square roots in it. So you can FOIL this out if you like, but this is what you end up with. Because when you FOIL it out, you're going to have a 4 square roots of 17 negative and a 4 square roots of 17 positive. They'll cancel each other out, and all you have left is the square root of 17 squared minus the square root of 4 squared. So down here, square of a square root is just what's in the inside. And 4 squared is 16, negative sign. So that's just going to leave us with a 1 down there. So it's just 11. Which is just so no more denominator other than 1. All right, how does that look? Any questions about that one? All right, so now, let's see. I just wanted to see how we're doing with time. All right. Remember, the process of solving a radical equation is to isolate radical on one side, other values on the other side, and then you square or cube or whatever it takes. In other words, you're doing the opposite of, this is cube root, so you're going to cube. So what we're going to do first is so adding 2 means it's going to be positive over there. And technically, this shouldn't be an equal sign. Let's just call it an arrow. There's only one equal sign, is that equal sign. All right, we get how that happens. That's the same old addition property of equality, where we, if we want to move something from one side of the other to the other, we just add the opposite. All right, now, to undo this and get the variable out, we've got to cube this. And if we cube one side, we got to cube the other side. So that means when we cube the cube root, the insides just come out. All right, now we just solve it just like a regular old linear equation. So that means 3x is equal to 9, and divide both sides by 3. I'm assuming you know that most by now, but all right. So let's go over and check and just make sure it works. I do think, like I said, this is just a kind of from my own experience. I think generally that the cube roots, you won't lose any odd root. I don't think you have any fifth roots or anything like that, or seventh. But you shouldn't lose it. But let's check anyway. So that's the cube root of 8. And the cube root of 8 is 2. Zero equal to 0 gives us a true statement. So this is our answer. All right. Any questions about that? All right. Now the next one is a square root one. I was just going to see what else is down here for a second. All right. This actually might be shorter than the second page might actually, or the second half might actually be shorter than what we've done already. All right, so this one we already got isolated radical, but we got a binomial on the other side, so we're going to have to either just FOIL x minus 1 times x minus 1, but watch first. We're going to square all right. So now when you when we square the square root, just the inside comes out. Now, like I said, you can square this out by FOIL, but I'm going to use that little shortcut method that they showed at the end of chapter 5. When you're squaring, you just square the ends. So that's going to be x squared, and then it's going to be 1 squared. Negative 1 squared is just 1, and that's going to be positive. Now, what I'm going to do is x times negative 1 is just negative x. Times 2 is negative 2x. So that result, you can get it by FOIL, or you can use that little shortcut That's what I'm doing. Now what? What do we do now? Okay, but we can't quite, I mean, we're going to do that, but not in this step. We first got to put all the terms on one side. So I'm going to subtract 13, and I'm going to add x. So see, these are going to be gone. And we've got 0 is equal to okay. Now we're going to factor. So this is pretty easy to factor because there's only two numbers. Well, these got to be negative here, so they got to be opposite signs. And there's only two numbers that are going to be one apart, and that's 4 and 3. And the larger one has to be negative. So x is equal to 4, or x is equal to negative 3. Now, I got a feeling one of these is going to not work, so that's why we got to check them. I won't say got a feeling. I'm pretty confident they are. One's going to not work. Which one it is, I would suspect it's probably this one, but I don't know for sure. So let's check. X is equal to 4. So we're just going to put 4 into the original. Wherever there's an x, we put a 4. So 13 minus 4 is 9 square root, and then 4 minus 1 is 3. Square root of 9 is 3, so 3 is equal to 3. Good news, this one is a solution. What about that next one? Is it going to work out? See if y'all can put it in there. So let's check x. Anybody got an idea where it works or not? Well, again, we're going to put x in place of x, we're going to put negative 3. All right, so that's 13, negative, negative, so that's 13 plus 3, which is 16. So these are not equal. So this is not a solution. We only got that one solution. So this is why checking them is pertinent. I know during a test you don't always have the the luxury of time, but if you've done everything right, I think mostly the cube roots will work. But with the square roots, you're generally going to lose one. All right, I guess we'll just keep going, and then like I said, yeah, there'll be a couple here that we can do. All right, so the thing you have to remember about the square root of a negative number is that the negative sign essentially kind of comes out and becomes an I. So once you do this, then it collapses into what we were doing earlier in the chapter, which was just simplifying that square root. In other words, it's like this one now. Because a negative sign inside of an even root, a square root, which is even, means that an I comes out. The negative sign turns to an I. All right. So 54 is 9 times 6, right? 9 is a perfect square. So the square root of 9 is 3. And as long as this can't be broken down any further, then we're finished. All right, try number 12. I really should be giving you a little bit more of an opportunity, and then we've been moving so fast. that should be pretty easy because all that is just collecting like terms. There's nothing different here when you're dealing with I rather than a variable in regards to addition and subtraction. So 4 and 7 is 11. Negative 5 plus 3 . All right, does that make sense? The reason why all of complex numbers was handled in that one section, 10.7, is because there's really only a couple of things you need to know. And there's two sides of the same coin. First is when you factor out a negative, it comes out as an I. In other words, the square root of negative 1 is equal to I. So in other words, if you just left that in by itself, let's show you like that comes out is that negative, is the I in front. And then like I said, then once we got that, then we move to that. Take out the largest perfect square we can, which is 9. Square root of 9 is 3, comes out in front. All right, let's take a little break. We'll come back in a few minutes. If you got any questions. All right, now just remember, anything with addition and subtraction involving I handles exactly like the old collecting like terms thing. You just have to be careful that when you're subtracting, just like other binomials, when you subtract, you've got to subtract everything inside of the parentheses. And then once you take care of that sign, that sign issue for both of those, then you can just collect like terms. You don't really need to have the parentheses there. And I probably could have up here just kind of written 4 plus 7, negative 5, I plus 3I. Just group them together. And by doing that, 4 plus 7. Oh, this was supposed to have been 11. So I don't know. This thing is, I'm either moving too fast or it's temperamental today. Because if you move too fast, it doesn't write anything. You're supposed to let me know about these foolish things. But it's going to be the same thing. It's still 11. And negative 5 plus 3 is negative 2i. All right, but what's different about the subtraction is we're going to take the opposite of each one of those. So this is going to be 5 plus 4 because it's negative 2. And so that's 5 plus 4 is 9. And then it's 9, take away 1. All right, any questions? All right, multiplication. The only thing we need to know is for these complex numbers is that I squared is equal to -1. It's the opposite of this. See, if you square both sides of this, square the square root to get the -1 out, you're also squaring the right side. So I squared is equal to -1. So when we're finished with any multiplication, we need to replace any I squareds with a -1. That's all. And essentially what it's going to do is it changes the sign of whatever that negative in the I square was attached to. It's going to be there with some coefficient in front of it. So we just got to distribute. There's two of them in there, so we multiply, and then we get the I squareds. We're going to change up to a -1. So 8 times 7 is what? Same old math. Yeah, it's 56, and there's one negative sign. So it's -56. And I times I is I squared. That's the one we're going to come back, because we can't leave an I squared in there because I squared is -1. And what that's effectively going to do is, rather than have an I squared term, it's going to turn it back to a real number. -8I plus 1. I'm sorry, -8I times -1. All right, so watch what happens is the -56 is still there, and it's multiplying the I squared, but the I squared is a -1. This right here is going to stay the same. So see, it's just going to change the sign of -56 to +56. And there we've got our complex number. Real part, imaginary part. All right, look that over and see if you see any issues. I'll be right back. All right. Y'all down with that? Real, imaginary part. That's what complex the number is. It has both elements. Oh, and just to note, I put an announcement in. In this instance, you can see it in Canvas. It goes out to whatever your default email is. But these are some workshops coming up. So, like I said, is your last day of class will be Thursday, and then the exam is about a week, from that, next Wednesday, essentially. We'll talk about it more Thursday about the date. But just from what I know about students, they don't get busy studying until, within, when they start seeing the exam coming closer. So just realize that's it. All right. So another multiplication. It's got eyes, so this time it's the first. Well, you know what? This is what we call the conjugate. So I'll work it out both ways, because so first, outside, inside, and last. All right? So what ends up happening when you do this, and I'll put it down here the short way. And we'll see if I know what I'm doing. All right? So let's work it out now the long way. I'm saying that this is going to be equal to 25 by using this principle. Now, the reason why when we had radicals and we were to do this, when we were rationalizing the denominator, we have a negative in the middle. But remember, that I squared is going to change that sign, so it's going to be a plus. But let's watch. First, it's 4 times 4. Outside, it's 4 times negative 3. These are going to be plus. The inside is plus because it's plus 3i and 4. And then notice, see why these work. These are going to be opposite, but we'll see it a little better in a minute. And then it's negative times positive. This worksheet's nice because it's got lots of room to do the problems. All right, so this is going to be 16. 4 times 4 is 16. This right here is positive 4 times negative 3i, so that's negative 12i. And then this was 3 positive times 4 positive I. Okay, see, these are going to be gone. And then here it's negative 3 times 3 is 9. I times I is I squared. All right, so how do we get up to 25? Well, watch. This is I squared. Okay. So I squared is negative 1. That's a 16, fellas, okay? I don't know why I can't get things straight today. So in either case, it's 25. Like I said, if you recognize that pattern with multiplying conjugates, you know that you're going to lose your middle terms. And also, when you got i's in your conjugates, you're going to change the sign, and it'll no longer be negative, you need positive. And again, that's why the complex numbers allow us to have a negative inside of a radical. All right, questions about that? Y'all okay on that? Or was y'all just sleeping? Let me know. All right, so 16 is squaring. We can do the same thing. Like I said, is see what. Oops, I missed it. Let's just multiply it out, and then I'll show you the short one if you want to. So this is 7 minus 2i times 7 minus 2i. Remember, you're going to have exactly 2 of the 7 times negative 2i's in the middle, and they're going to combine, and that's why the formula works. So first is 7 times 7. Outside is negative 14. Inside is negative 14i. And then negative times negative is positive. 2i times 2i. All right. So 49 minus 28i plus 4i squared. Now, there never should be an I squared left inside because the I squared is equal to negative 1. And the negative 1, all it does is just change the sign of this thing. All right? It's no longer going to be a positive 4. It's going to be a negative 4. Hence, that's why you can take a 2i times a 2i and end up with a negative 4. And like I said, you can kind of do the same thing following the formula. It's 7 squared minus 2 times 7 times 2. So that's so it's a little bit shorter. And then this is going to be 4i squared, which is what we had down here. So like I said, it ends up being the same thing because that's going to be negative 4. And then from the 49 is 45. All right, questions about that? So that's all of the odd stuff. All right, so square root property. That's where we're going to take the square root of both sides. So let me give you a minute to see if you want to work on that. And then I'll go through it. We've got a good amount of time left. And just incidentally, about these, when you multiply, you always end up with an I-squared. You change it to a -1. And so these will always have a real and an imaginary part. Now, the exception is this, because this is the conjugate. And the reason why we multiply by that conjugate is to eliminate any of the I terms, and it ends up just being a whole number. All right, so this just does the square. So we got x minus 5 is equal to what? Plus or minus 4. We got to remember the plus or minus. I usually put the plus or minus right as soon as I take the square root, because otherwise I might forget it. But you got to have that plus and minus in order to get both solutions, because these are quadratics. So adding 5 here so x is equal to 5 minus 4, which looks to be 1. And then x is equal to 5 plus 4, which is 9. All right, any questions about that one? So we were all right on these? Oh, just incidentally, let's see if there's make sure there's an exam review in here. You can use the exam review in My Math Lab, but that's kind of hard to go over. See, there's the final exam practice. So I'll be looking at that on Thursday. All right. So what's going to happen on the next phase of this, the next step? So this part's going to pop out. That's the reason why we're doing it. It's just going to pop out. But what happens here? What's the square root of negative 81? It's not negative 9, it's 9i. All right? All right, and then just to show you, it's two solutions, so you can write it as x is equal to negative 7 minus 9i, and x is equal to negative 7 plus. All right, any questions or comments on that one? All right, so on these quadratic formulas, which is the last thing that we covered, we just got to figure out what's A, what's B, and what's C. Okay, now, we're doing that because of this. I'll write it up here. When it's in this form, in other words, when all of the terms, like terms are all collected and then they're all set on one side, and set equal to 0, then as this one is, then the A is the number in front of the x squared, which is 3. The B is number in front of the x term, which is negative 5. And what's C? What's C? Negative 2, yeah. Okay, now remember, this is the quadratic formula. I messed up. All right, so negative b plus or minus the square root of b squared minus 4ac over 2a. So give that one a try, and in a couple of minutes I'll come behind you. Okay, so remember, there's a negative sign in front of that b there. That means that if the b also happens to be negative, you got to account for that. You can't just leave off the negative sign. So it's a negative of a negative 5 4 times. A 4 is built in, just like the 2 down there. It's a negative 4. A, which is 3. And then the C is negative 2. All over 2 times 3. So negative and negative 5 means positive 5 plus or minus. So negative 5 squared is 25. Now we got negative 4 times a negative 2. So that's going to be a positive 24 all over 6. So we take it nice and slow. And that's square root of 49. So the good thing about the quadratic formula is it will solve any quadratic, even those that are not factorable. And you can also use it if you somehow, you can't find a factorable solution to a quadratic. You can use this to see if you make a mistake. Now, if it comes out to where everything is whole numbers or fractional, then it could be factored. It can be factored, but if it's got a radical in it, in other words, sort of like this one, and now these were both factorable. This one was factorable. This one wasn't because the i's are not. Now, if you're some kind of savant, you might be able to factor it, but generally speaking, no. All right, so here's the two solutions. 5 minus 7/6, or 5 plus 7/6. So what's that one going to be? Once we simplify it, you got to simplify them all the way down. Good. So this is negative 1/3. And then this is 2. 12 divided by 6. Yeah. So both of these would have been factorable. You know, so it might be a longer method, and like I said, is the downside of factoring is because you still have to do the searching for the two numbers, and especially when you got a value in front of the x squared, like this, like 3, then you got to use that long method that I showed you, and like I said, is so you can use the quadratic though to figure out, and then you can see what the solutions are. And you can just back out from each one of these. So this one would be x is equal to 2. So x minus 2 is equal to 0. So x minus 2 would be in one of the factors. And then this one would be 3x plus 1. Factorable, wise, if you needed the factors. All right, so what do we need to do on this one? I mean, is this one ready to go? Yeah, you got to say it equal to 0. In other words, we got a plus 1. Because just like factoring, we got to set it equal to 0 for this to work. All right, now, if you use your square root property, but of course it's got to be in this form, then that's the one exception where you don't have to set equal to 0. You just got the square term equal to a number and then take the square root of both sides. And I think I told you this is actually part of a larger method called completing the square. So if you're going to math 130, which is college algebra, and that's usually for people that want to get a bachelor's degree at some point, then you're going to find that that's in there, and you find the whole procedure, and you can use it for certain things. All right, so now it's set equal to 0. A is equal to 6. B is equal to 12. C is equal to 1. All right, so that means we're going to get our solutions by x is equal to negative b, which is 12. Now, this is neither here nor there, and it wouldn't work for this one anyway, but let's just say that this were a 12. We could divide everything by 6, and then the numbers would be small. We could just use those. But there's no way to simplify that down here, but I was just mentioning that because it could make the number smaller if everything could be divided by the same number, and then you could use a less complicated quadratic. So it's negative 12 12 squared minus 4 times A, which is 6, and C, which is 1. So 12 squared is 144. And then this is minus 120. I'm sorry, minus 24. Just one negative sign. Another 12 down there. All right, and then 144 minus 24, does that give us a perfect square? I don't think it does. Let's see. It's 120. Make sure I wasn't making a mistake, because I was hoping it would be a perfect square. So this one's going to have a radical in it no matter what. You wouldn't have been able to factor this. So all right, so the one thing I need to do is I got to find the largest perfect square. So let's just kind of climb up the ladder. All right. So 120 divided by 4. 4 is a perfect square. Oops. So 30. Does 30 have a perfect square in it? Well, let's just go up the line. 2 so divided by 9. I don't think it is. I think it's 4 is the largest one. Definitely not 25. But I just want to make sure. Because we'll have to do it again if we're not. And then let's see, I think 49 will be the next one. The 7 squared. 8 squared is 64. I definitely think we're did I hit divided by? Yeah, I did. Okay, so the largest one is 4. All right, so the 4 is going to come out as a 2. Square root of 4 is 2. And as long as 30 doesn't contain any perfect squares, we're going to be done with that radical part. So like I said, as you can count, even if you don't get the largest perfect square out and you leave one in there, you can just kind of go back through. So 30 divided by 4 is not perfect square. So divided by 9, it's going to be no good. And 30 divided by 16 is no good. Okay, so that's it as far as the we can simplify this down by taking all 3 of these are divisible by 2. We can do that. It's got to go into all of them. So 2 goes into there once. It goes into here 6 and into here 6. So we're left with negative 6 plus or minus over 6. So that's about all we can do. If they want you to separate them, then you got to do it like this. You know, do the negative 6 minus the square root of 30 over 6. So there's the 2 solutions. And you can't really simplify that any further. You could divide this 6 into that and get negative 1, but there's nothing else to divide that into, so it would just be negative square root of 30 over 6. So that's best to leave it like that. But I think that my math lab, as I remember, wants you to break them up and separate with a comma. All right, so